What was that? Well, we're getting an echo from the room. So do you guys say halug or halug? Oh, we're having sound issues. Sarah and I can hear each other, so it's just the room. Too loud. Okay, sorry. Great, thanks, Will. So we could start, and if questions arise, we could do them in the chat. And if you get the mic working, that's great. So he says, great. Yeah, so why don't I hand it to you? I'm going to mute the camera. I'll hand it to you.
Let me go ahead and share my screen here. All right, well, welcome everyone. Thanks for the opportunity to present today. We're here to talk about security. So I'm Sarah Zalusky. I'm a partner and staff engineer here at JKI. I'm a long-time LabVIEW user. I've been a LabVIEW developer for about 20 years. I've been at JKI for about 11 years. And during that time, I've led the development effort on many of our larger production systems, which are all LabVIEW based, many of those in the semiconductor industry. And then more recently, I've been doing quite a bit in aerospace as well. A little bit of background on JKI for those of you who may not be familiar with us. We've been around for 25 years. We're primarily a custom software solutions consulting company, but we have a very long track record of delivering tools that really bring software engineering, modern software engineering tools to the LabVIEW community. I'm hearing a little bit of background. Okay, thank you. I wanted to call out that we serve many different industries. So semiconductor, I mentioned, around 2018, we really started expanding into mil-aero. Around 2020 and 2021, we got our first major NASA project. This was a data acquisition upgrade for the NASA Ames project facility. So it's a heat shield testing facility. In the course of working on that project, we were subject to NASA's 7150 standard. And if any of you are familiar with that, this is a very rigorous standard that really mandates how you develop software and develop, test, deliver software, and also says a lot about the security and quality standards that you need to meet in your software. So in the course of delivering on that project, we have been working on and developing some security tools that helped us to be compliant with 7150. And in 2024, we started releasing some of those capabilities to a wider audience. And we've been working with other teams in the LabVIEW community to solve some of their security challenges. I want to talk a little bit about the security landscape in 2026. There are a number of drivers which are really changing the way in which teams need to think about security. One of the major drivers is really a technological transformation, which is happening right now. I'm going to say the word AI once in this presentation, but AI is really driving a push for a lot of data to be aggregated across systems that used to be isolated in the past. So a lot of the test systems or manufacturing systems that we work on never used to be interconnected. And now there's a big motivation in order to collect this shared operational data for all those systems to be connected. There's also a massive regulatory shift, which is happening right now. We talk to a lot of our customers and it impacts our business in a lot of different ways. The two primary drivers, if you work with the DoD or DOE in the US, this Cybersecurity Maturity Model Certification or CMMC has a number of regulations that impact how we develop secure software. Another one, which we've been having a lot of conversations about recently, is the EU Cyber Resilience Act or European CRA. This has very stringent mandates for how you develop and secure your software if you're shipping products in the EU. This presents a lot of challenges for LabVIEW teams, whether you have compliance drivers or just want to do best quality, follow good quality software practices. One of the issues for LabVIEW teams is that you can't expect every developer to become a cybersecurity expert. Many smaller teams don't have a dedicated security staff. If you're on a bigger team, your security staff may be more IT oriented and not as used to security, which impacts operational technology. And there's not been a clear path or tooling that's been specifically designed for LabVIEW. One other statement about why security matters, particularly for us as LabVIEW developers. In general, when we talk about security breaches for IT systems, this usually means data exposure. This is still not good, but these are things like user data or financial data, which can still be damaging. But the types of systems that we typically work on, these are test and automation systems. So often these control physical processes. We talk to physical hardware. We validate critical components. We might work on safety critical systems. So if we have a security breach in these systems, the impact can be extremely high. It can cause damage to equipment. It can shut down your whole production system. There could be safety implications. And then the other aspect is, especially if you work on a manufacturing or test system that impacts production, if you deliver products which have security vulnerabilities that are introduced by means of production or test, this can continue to propagate and spread issues even beyond our own systems that we work on. The good news is that while the security landscape is changing and is broad in 2026, there are a few fundamental concepts for security that are really general, high importance, and have broad applicability across those two main standards that we talked to, and also just in general industry best practices. And if we think about security in this way, and we ask these questions within our organization, we'll be in a better position for meeting security challenges in 2026 and beyond. So the fundamental pillars are, the first one is addressing the software supply chain. This is fundamentally asking the question of what is in your software and is it known to be safe? Security testing and remediation. Did you test your software for security vulnerabilities and are you able to fix what you found? And then the third is having a secure development process. A lot of these regulations require that security it's not an add-on secondary consideration. It's something that we as developers think about and design in from the very beginning. So let's dive into the first pillar, the software supply chain. What is in your software and is it safe? So first we need to define the software supply chain. This is a very comprehensive set of everything which is in your software. So any external code, components that your software depends on, your own software, and all of the infrastructure and process that you use to develop, build, and deliver it. So it's a very comprehensive list of what gets delivered in your software and also essentially everything that has touched your software throughout its life cycle. Why is the software supply chain important? I like to use this graphic, and this is the common one that you see when we talk about the software supply chain, because it really illustrates that The tip of the iceberg, which is above the water, is your LabVIEW application. So this is your custom business logic, your code, which you are writing. But below the surface of the water is your supply chain, and these are all of the other things which are contained in your software. So at the very top, we have direct dependencies. These are the things which your application is directly calling. These could be VIPM packages, these could be NI packages, these could be other kinds of third-party components that you're directly calling in your application, but may not be packaged in a standard way. Then you have things like platform dependencies. So this is all of your LabVIEW dependencies, all of your NI drivers. Then you have this large category of what are called transitive dependencies. So these are any of the dependencies of your dependencies. And this could get quite large. These are things like DLLs, interop assemblies, other third-party components, things which you're not intentionally bringing into your application, but come as dependencies of the other tools and components which you're using. And as you can see, most of your application's attack surface is below the waterline. And one of the reasons this is really important is that you may have something in your transitive dependencies which introduces a pretty severe security vulnerability. And the impact of that could be pretty far-reaching. I also wanted to call out that I have a couple little ice cubes floating out here. That's to indicate that in addition to your dependencies that we've talked about, the supply chain also includes infrastructure, processes, configuration management, some of these other aspects that we're not focusing on today. Today, we're really focusing on what is in your software, because this is something that we as developers have a lot of control and visibility on. I have a slide like this for each one of the sections. This is mostly for your reference for later, but this is helping you to understand what the regulatory drivers are and how we arrived at the three different pillars and what that mapping looks like. But in general, both CRA and CMMC specifically require you to have visibility and management of your supply chain. The fundamental question is, what is in my software? How do we answer this question? The standard way in which we answer this question is by putting together a software bill of materials, or an SBOM. And this is a written, complete, machine-readable inventory of all the components that you have in your software. There are a handful of standard formats. Cyclone DX is the one that we're mostly going to talk about today. This is what most of our customers are asking for. But the most important information that is in here is your list of primary dependencies and identifying information for all of those primary dependencies. So again, those are NI packages, VI packages, or other non-packaged third-party components that your software is directly calling. For each one of those dependencies, we need to have a component name. We need good versioning information, supplier name. And then there's typically another set of unique identifiers which can be used to locate more information about that component. If you have a package dependency, then this package uniform resource locator, or PURL, this is essentially the link to that package wherever it's publicly hosted. And then there are other digital signatures which could exist in here, hashes of your source or executable, things that allow you to later verify that the component that you have on your system matches the source or matches what it was expected to be. And then SBOMs can have this extended data set, which is over here on the right. So these are things like licensing information or restrictions. As we all know, open source components often have different flavors of open source licensing agreements attached to them. And we want to know, as developers of our software, if we've included anything that gives, has specific obligations for the way in which that software can be later distributed. There can also be extended dependency information in here. So in addition to primary dependencies, we may have a deeper scan that gives information about the dependencies of our dependencies, and also some visibility on this dependency tree. So what is the relationship between different components that we have? Some of these also support CVE data, or list vulnerabilities that are known for the packages or components that are listed, and we'll talk more about what those are. Okay, so I've been able to answer this question of what is in my software. The second part of this is knowing whether what is in my software is safe. How do I answer this question? There is a program that was originated by MITRE, and it is this public database of vulnerabilities that have been defined and cataloged that are listed here. And this is a public data set that you can go and cross-reference with your component to see there are known issues, security issues in the software component that have been released in the wild. These are things which are documented after the fact. So that means there's a real product that exists, a security vulnerability has been identified in it. And oftentimes, if it's listed on the CVE database, there'll be mitigation guidance of how you can address that issue if you happen to have that component as a dependency of your application. So it's a standardized system, and organizations all around the world, including NI Emerson, contribute to this data set. So here's an example. If you go to the CVE website today and do a search for LabVIEW or other NI products, you will find information about vulnerabilities that exist in LabVIEW or NI products. Oftentimes there's mitigation guidance, which is, okay, you need to upgrade to the latest version because their team has already addressed those security issues. How do I put this into practice to secure my supply chain? We've talked about the first step, which is knowing what's in your software. I need to be able to generate my SBOM. Maybe I need to do a deep review of my transitive dependencies. I need to validate that this is safe. So I need to take my list of dependencies and I need to validate that those dependencies don't have known vulnerabilities in these vulnerability databases. Then I need to review that list. I need to fix issues if I can do mitigation, if I can upgrade that component. And I need to create a documentation trail of this is what I've done. There either were vulnerabilities that have been fixed or there were nothing detected. And then the other part, which is important for us and puts a burden on developer teams, is that it's our responsibility to continuously monitor to make sure there are no known issues that develop over time. Meaning that on day one, I've done my due diligence, I've delivered my software, there's nothing that's been documented as a vulnerability, all good to go. But over time, an issue may be found in one of those components. And it's my responsibility to kind of retroactively go and upgrade systems that have released in the wild and have issues that are later detected. So one thing that I wanted to call out is that there are tools which are specifically designed to help you manage security of your software supply chain. These are called software composition analysis tools. For text-based languages, there are a myriad of tools that exist that do this for you. If you don't have tools to do this, there's a lot of manual process involved in generating your SBOM, doing this cross-referencing against known data sets, and then doing continuous monitoring over the entire life cycle of your product. So JKI has been working on expanding some of our security tools. One thing that we've been working on is this SBOM generation tool, which allows you to scan a project and list in Cyclone DX format all of the primary dependencies which are in there. So VI packages or NI packages is what it supports right now. This is something that we expect to have available to the LabVIEW community in the NI Connect timeframe. And I'd be happy to chat more with folks if they're interested to learn about it. Another important consideration is that generating your SBOM is really only the first step. You're still responsible for doing this cross-referencing against the CVE database. This is also an area where JKI is investing in putting some energy into coming up with a solution that works for LabVIEW. One of the things, if you are subject to CRA, starting in September, teams are responsible for collecting information about security issues from their user base, having a process in place to do mitigation, and then having a means to disclose this information to affected parties. So there's this whole chain of documentation and process which doesn't exist for most of our teams that deliver LabVIEW-based products. And we're looking at ways in which the VIPM infrastructure might be able to help teams to collect this data set and be able to share it with their end customers. One other thing about this is that right now, the level of maturity for security documentation in the LabVIEW community is pretty low. So if anyone has an OpenG dependency in their code and someone asks you, are there any known vulnerabilities in the OpenG configuration utilities? You'd say, no, there's no known vulnerabilities, but it's because no documentation exists and the due diligence to review those components hasn't been done. It doesn't mean that there aren't issues. So this is something for all of us as a community we'll need to figure out and address together, because many of us have, production shipping products which have dependencies on some of these open source tools. In summary, for software supply chain security, what is in my software and is it safe? In general, you can use tools like a software composition analysis tool. This is the traditional way in which this problem has been solved for other languages. The alternative right now is that you can do some manual checking. You can do manual generation of your SBOM. Starting May, you can use the JKI tooling to generate an SBOM and then manually cross-reference that against the CVE records. I will say that there are some open source tools, preliminary tools that do SBOM generation that have been created by community members. So you can always do a quick Google and explore and find out what is available there. In terms of the deliverables for this first pillar, what most of those regulations are asking for are the generation of your SBOM and then this proof of CVE monitoring over time. All right, pillar 2, security testing and remediation. This is asking the question of, did you test your software for security issues? And did you fix what you found? So what is security testing? Security testing is a little bit different than the kinds of functional testing or integration testing that we typically do on our systems. This is a systematic evaluation of your software to look for security flaws that could compromise your system. And security teams typically look for flaws in 2 places. So one of the big ones is looking at entry points to your application. This is any place where an external threat could interact with your system. So for a typical LabVIEW application, these are things like your user interface. This is one of the biggest surfaces because this is the way in which the user interacts directly with your application. They might input data. File inputs, if you have network comms, database operations, external code, hardware inputs, but you get the sense it's really anything which is an external entry point into your application. And then the whole second category of flaws that security teams look for are really internal weaknesses. And there's a huge overlap between software quality and security when we talk about internal weaknesses, because these are oftentimes just poor coding practices or patterns that could be exploited. These are things that could cause instability in your application. So common things are things like, race conditions, having hard-coded credentials in there is bad, deadlocks, not having good control of your resources, or memory violations. There's a large number of examples, but those are some. Why does it matter that we do security testing? So all software has security flaws, just like all of our software has bugs. And the point of doing regular security testing is that we are able to identify and mitigate these issues early on in the process where it's less expensive and less time consuming to do so. So I have this little chart down here that talks about the impact and cost to correct security flaws. So during development, this is something that if you have a rigorous security review or you have good tooling, that you're making security considerations early on in the development process, this is something that could be fixed in a very short period of time, very low impact. Once it gets into testing, maybe you need to do a rebuild. There's a little bit more documentation at that point. There's a little bit more impact to schedule. Once a security flaw gets released into production, this is already beginning to become problematic, even if it hasn't been exploited, because I may need to deploy an emergency patch. Depending on the way in which you deploy your systems, this could be logistically challenging, right? Some of us still deploy on air-gapped systems or in really controlled environments where it's problematic to do upgrades, and it introduces system downtime. And then after exploitation, this is the worst possible time to identify a security flaw. in addition to all the things below, you have the full impact of whatever that exploitation was, and then you have breach notification and other legal or documentation burden for your end customers. Again, regulatory drivers. Specific security-focused testing is becoming less and less optional. And for both CRA and for CMMC, there are specific callouts for the ways in which you must do security testing. NIST 800-171, if you're subject to that, specifically mentions certain types of security testing which must be done. Okay, so let's put this into practice. There are two standard approaches to security testing. The first category is called dynamic code analysis. In this type of security testing, you probe a running application from the outside to find those documented vulnerabilities. So those are the CVEs, which we encountered earlier. The good news for LabVIEW, and the reason why you don't hear us talking much about this, is that traditional tools still generally work, especially in places where you have a standard interface to your application. Think having a standard REST API, or if you're using web services. The other category of security testing is called static code analysis. And with this type of security testing, you inspect your source code for code quality and security issues before the code is executed. And these capture software weaknesses. And specialized tools for LabVIEW are required to do this because LabVIEW is not a text-based language. It's a data flow language, and it's a visual language. So static tests, what kinds of things can we find in a static analysis security tool? Similar to the CVEs, which we encountered earlier, MITRE has also put together a separate dictionary of software and hardware vulnerabilities. And the nice thing about this is it provides a language and technology agnostic standard terms in which we can talk about the common kinds of weaknesses that exist in software. If you're new to CWEs, I recommend that you check out some of these resources, which I've linked, because JKI has spent a lot of time in the past talking about CWEs and how they impact LabVIEW specifically. Last year at the Security Summit, we had a talk about specifically this, and then we also have a good article that is JKI's top 25 CWEs. The standard, as we said, is language agnostic. So there are many things which are listed and are listed as high priority issues, which may not be applicable to LabVIEW. So let's look at some examples of things which we could find with a SAST tool. There are things like identifying situations where you might have race conditions in your code, identifying situations where you might have an integer overflow and you have some logic that is not prepared to handle overflow scenarios. You might have uninitialized variables. In LabVIEW, this typically means maybe I have an uninitialized shift register. Maybe that's intentional. Maybe it was accidental. Maybe I'm using obsolete functions or dangerous functions. These are things often which are deprecated or no longer recommended parts of the language that you should be using. And also finding things like deadlock. So I want to walk through a specific example of what a CWE could look like in LabVIEW and how we could find it and understand what it's doing. So CWE 78, this is dealing with improper neutralization of elements used in an OS command. Many of you are probably familiar with the way in which we can do OS command injection in LabVIEW, and that's with the system exec function. So this is an interface to the command line that you can call within a VI. This gives us incredible power to be able to, directly call things from the command line in LabVIEW, but care needs to be put into how data from an external source, a user or a file, gets fed into the command line. Because this is a powerful function, there is opportunity for some nefarious actions to happen. So in this example, I want to find the process ID for my process, for my application. So I have this nice reusable VI. I'm able to pass in my process name And then presumably I'm gonna get the list of the task that's output and get my process ID out on the other side. You can see here, if I don't put filtering in place to make sure that this is a properly constructed argument, an outside user could do something nefarious like request recursive removal of your C drive. Obviously, this is a very dangerous situation that could be exploited, and a way that a static analysis tool could help protect against this is to go and identify all the locations in your LabVIEW code in which the system exec function is being called, and make sure that we have provisions to do appropriate filtering and input validation on what comes in. So what SaaS tools are available for LabVIEW? I'm going to give a quick demo of the JKI Security Suite, which is a security-focused static analysis tool that was written exactly to serve this need for the LabVIEW community. I do want to mention that VI Analyzer is also a static analysis tool. This is a great extensible tool. Definitely still recommend for people to use it. It does not have the security-focused features that the JKI Security Suite has, meaning that it's great out of the box for finding quality issues. It could be extended with a lot of manual effort to start to get some of the CWE coverage that we have in our security tool. And then the last option, this is not really a SaaS tool, but this is one way in which we see teams addressing this need, is by doing manual reviews. This is something that's very time consuming. It's something that's inconsistent. But I might have a security checklist where I need to go and review every VI which has been written and identify any security issues which could be in there. So I'm going to do a quick demo of the JKI Security Suite. I'm going to try not to take too much time and just give you an overview of key features. But this is installed on my system. Everything is accessible from the standard menu. So I'm going to open the crawler tool. This tool is meant to be run also from the command line, so it can be integrated into your CI/CD pipeline, but I'm going to show you the desktop version of this tool. So this is a static analysis tool. I'm going to pass in a path that I have on disk with some test code. I'm just going to run it so you can see what this output looks like. I'm going to select the very simple rule set, which is essentially just giving me some property inspector type information about all of the VIs which are contained in there. And the output that you see here is the same output that you would see if it were being piped to the console if you're running it from the command line. So in terms of creating build artifacts and that sort of thing, this can be used in that way. All right, so it's going to take a little bit of time. All right, the run has completed, and I can see that I have two types of reports which were generated. One is a standard CSV file. This has information about which VIs were evaluated and any results from the scan. I also have this JDB file. This is a database file which I can explore using the other primary tool which is part of the security suite, which is the JCrawler Explorer. This tool is a great way to visualize the results from my run. I'm going to go ahead and load this test that I just ran. And I can see that I had one file that failed. Let's dig in here and try to understand what happened. It looks like I had a file that was on disk that was saved in an incompatible LabVIEW version. So I know that I have some code sitting in there. Maybe I need to clean it out or review. But generally, there's not as much interesting information in just the metric scan. You can see that I scanned 112 items. I identified a bunch of properties. I'm going to load some results from a scan that I ran a little bit earlier today. This one, I ran our full security set of rules against. And you can see that it has tagging for some specific CWEs that were identified in the code base. So let's take a look at some of this down here. And I can see that our CWE 78, so this is the improper neutralization for the OS command. This same CWE has been flagged in our code base. So it means that somebody is calling the system exec function, and we're giving you some information about what the issue is and some mitigation guidance of what things we might be able to do to prevent that from being a security issue that could be exploited. So the other nice thing about this tool is that I'm able to copy this bookmark here. And if I go and review that VI as a developer, paste this bookmark and put some comments in the code about the fact that it was reviewed, it was safe, this allows the tool on the next scan to pass that particular VI or that particular node. So I can see here, here's another instance of that CWE 78. And in this circumstance, somebody has reviewed it. They've said that, hey, a constant is wired, nothing can be injected, so I don't need to worry about this particular VI. And here's another instance where one of my team members reviewed a situation where I had potential deadlock, and they reviewed it, left a comment in here. So now I know that I don't need to worry about it. So I'm going to also show you that if I want to learn more information about the different rule sets or their behavior, there's pretty good in-product documentation on this. So I can find information about the various different kinds of rules. I can find information about the full command line interface, how to construct the command line call. I also want to call out that from the tool, you also have access to our cybersecurity software development plan. This is a subset of what was in our full 7150 compliant process that we followed for that NASA project. But it gives your team a really good guide and overview of how we can integrate these security best practices into our standard developer workflow. And it does the job of mapping some of those things which are hard or different when we do LabVIEW development versus some of the other development flows that are out there. All right, I'm going to hop back over to my presentation here. I'll talk a little bit about the product roadmap and updates. So the JKI Security Suite is available now. It's part of our early access program. We're in phase 2 of our early access program. And this has been a pretty successful soft launch to understand whether the tool is meeting the needs of our customers and getting good feedback to improve it. So we are planning to have a public and general release of this tool at NI Connect in May this year, which is right around the corner. In between now and then, we're really building out additional CWE coverage. These are things that the tool can automatically detect, weaknesses the tool can automatically detect in your code. We're also working on integrating the SBOM features. Is there a question? We're also working on integrating the, sorry, there's a little bit of background. The SBOM capabilities that I shared earlier as a native part of the tool. And we're also working on thinking about extending these capabilities to include more traditional software composition analysis. So that would be vulnerability management and scanning after the fact. And we'd be happy to talk more with your team about this if you're interested. Security testing and remediation summary. So this was the second pillar. Did you test your software for security issues and can you fix what you found? I wanted to call out that there are 2 different categories of tools which really help teams to solve this issue.
Hey, Sarah, they're going to pop off and pop back on to try to resolve their audio issue.
Oh, are they not able to hear us now?
No, I think they can hear you, but I think they just can't speak.
Okay.
Maybe they did lose our audio. If that's the case,
no.
then
Hopefully it hasn't been lost for too long.
yeah. Yeah. The problem we're seeing, man, those are some nice slides. Let's see.
It's hard to get used to the black box presentation.
Yeah. Oh, I might have to let it back in too. So let me just stay on top of that. Okay, let's see if they're jumping back in. We are back, they say. So they're in his Hamilton. So
Okay.
you can keep rocking.
Okay, you're able to hear me. All good. So summary for pillar 2, security testing and remediation. Right? Did we test it? Did we fix what we found? The deliverables here are typically scan reports or manual results indicating that you checked for specific CWEs and either found them or didn't. You'd use a SAS tool for that. And documentation on any of the vulnerabilities in any of your components. So cross-referencing with the SBOM. Remediation evidence is also important documentation. Okay, so third pillar, secure development process. Is security central to your development process? This is a big aspect of many of the regulations now, especially CRA. They really are asking for evidence that your team is considering security throughout the life cycle of your application, and it's not just something which is added on to the end. Many mandate specifically that you have a documented secure development process. And as I just talked about, it really needs to integrate security into every aspect, every phase of the software development lifecycle. So this starts with design, develop, build, test, deploy. Another thing to call out is for many of these, the maintenance is also important. So that vulnerability management and monitoring needs to take place even after deployment, after products have been delivered to the end customer. Why does this matter? I like to think about security programs similar to the way in which we think about safety programs. We like to use a layering approach because we recognize that nothing is ever going to be 100% perfect or 100% secure. So we try to put a lot of layers in there to protect where there are potentially gaps. And you can see here, I have secure design, develop, build, test, and deployment. All of these things work together to improve the overall security of your application. In terms of regulatory drivers, I just mentioned CRA. This is something which is strictly required, also applicable for NIST 800-171. Putting it into practice, you really need to have documented evidence of the process which you plan to follow and records that that process was followed along the way. There's been a significant effort in the LabVIEW community in general to try to address this specifically for LabVIEW development. I'm not going to spend a huge amount of time talking about it today, but in general, you can think about it as, even at the design phase, there are entire categories of security issues that could be designed out. So really, the earlier that we shift our thinking to earlier in the development life cycle, the better prepared we're going to be. One thing to note, and I shared this with you, this is something that you get access to from the JKI Security Suite, but we do have a secure software development plan, and we have been working with teams and training teams and having conversations with them about how to bring secure development practices into their LabVIEW workflows. And we'd be happy to chat more about that with you. I'll also note that our secure software development plan is based on NASA 7150. So if you have other standards that you need to be subject to, we can work with you to understand where the gaps are there. Key takeaways: the regulatory landscape and the security landscape in general in 2026 is challenging. There continues to be additional pressure that is mounting all of the time for us as LabVIEW developers. Some of the customers that we've talked to recently are under intense pressure already to address some of these questions for their teams. Others may not feel that pressure yet, but if they're delivering products in Europe and just in general, more of this pressure is coming for us in the near future. So it's better to be proactive with your team and understand what industry best practices are. So if you can answer even one of these questions for your organization, it will really greatly improve your security posture. And just to reiterate, software supply chain security, asking the question is, what is in your software and is it safe? Security testing and remediation, right? Did you test it and can you fix what you find? And then secure development process is asking the question of whether security is central to your development process. And the other thing that I wanted to call out here is that the burden of compliance and the burden of resolving and addressing these for your team is pretty high. For all of us, it's time that the team invests, it's company resources that the team invests. And traditionally, the way this problem has been solved outside of the LabVIEW community is to develop really good quality tools that you can use to help you solve this problem, help you have kind of continuous feedback and reinforce your development process that you put in place. Not all of us have the time to become cybersecurity experts, so the tooling that we have can make a big difference. All right, so that's the end of my presentation content for today. Hopefully we can find some way of getting questions back into the chat. But yeah, if you'd like to continue the conversation about security, we'd love to learn about what your team's challenges are. And if any of the things in this talk resonated with you today, if you're subject to CMMC or CRA, yeah, we'd love to continue the conversation with you.
Can you guys hear us? And do you have any questions? Anybody want to make any comments? We can hear you, Hamilton says. So maybe no mic on their side. Does anybody have any questions? So apparently the mic does not work. No, it doesn't. Oh, I think we're getting an echo from me. I'm not sure. We got a little green halo.
We will be at NI Connect this year. So if anyone is there, please come talk to us. I'd love to see some of your faces and talk in person. We'll also be at the GDevCon NA in July. So those are both good venues to talk more about security.
Yeah. Are there any burning questions that somebody wants to type into the chat? Well, so there's a question. There's apparently some Modbus hate out there. So they would like to know if these new security regulations will kill Modbus. Do you want to weigh in on this hot topic?
I doubt that Modbus is going away anytime soon.
That's my read as well. I think that for those of us who don't care for Modbus, it'll still be a sad future.
It's an important thought, though, that in the past, some of these industrial networks have been exempt from security, right? We don't think about it in the same way, but the way in which the shift is happening right now, we're going to be revisiting conversations about industrial comms.
Yeah. And you know, Sarah's been working on this problem for multiple years. I've been around the LabVIEW community for a long time, since '96, I guess. And I've been getting more into these security issues. And it's really there's a burning intensity at some organizations around this topic, and it's spreading. People who do more business in Europe are talking about it more. Our defense subcontractors we work with are talking about it a great deal. But then we're seeing life sciences people showing concern. They of course have global reach, but okay. Oh, so Sarah, question about the pricing of the security suite.
Yeah, we don't have our public pricing listed yet for the release, but that will be coming very soon. And if you're interested to talk to us about early access ahead of May, please reach out.
Yeah, shoot us an email.
Yeah. I can say that the SBOM capability is going to be available in the community, but that's not the full security suite.
So I just put our emails in the chat. And I even spelled Sarah's name correctly. So that's,
Yeah.
I do that better than some. Sometimes your name gets misspelled. We can email it to you, Hamilton and team, with the slides. Ask for the slides. We're gonna, the slides will contain everything but the demo. There we go. So we got an email. All right. Anything else you guys want to drop in here? Is there any other protocols that someone wants to share their views? That it's not their favorite protocol? We'll take those two. It can be a little bit of protocol therapy. All right. Okay, I think it's just you and I talking to each other at this point, Sarah.
Okay.
So we can do that a lot.
Thank you for hosting us today.
Awesome. Thanks, guys. Yeah, we appreciate it. Wish we could be there in person. I've had the opportunity to get out to Huntsville a couple of times, and I was doing some model-based systems engineering work. So if anybody wants to talk model-based systems engineering, you can also reach out to me about that stuff too. All right. Talk to you guys. Bye.
Thank you.